Hi, welcome to a new session of analog circuits. In today's class 7, under PN junction diode rectifier, we are going to see a special filter called inductor filter and application of inductor filter in a particular rectifier, whether it is a half wave or a full wave. Here you can see there are two types of rectifiers just shown over here. It's a center tapped full wave rectifier, and this MATLAB model is a bridge rectifier. So in our past classes, we have seen exactly what is the outputs of half wave rectifier and full wave rectifier. So what happens in a particular rectifier circuit where input of the rectifier is coming from a transformer and rectifier output it is given as input to a filter, then filter it will filter out some of the problems which are involved with the waveform of rectifier, and it will give a new output, and that output is given as an input to a regulator, or you can use a tuning method in order to obtain the final output which is of our requirement. Exactly, we require a DC output, so for that we are using this tuning with the help of a regulator. So what happens when a transformer is taken as a mediator between input and uh, input to a rectifier? So you can see the transformer output which is acting as input to a rectifier. It is nothing but AC in nature, that is sinusoidal voltage. Then output of this rectifier, when it is a full wave rectifier, you're going to obtain a unidirectional output in this fashion. Then we are using filter, and its output seems to be like this. You can see here in a rectifier output, the unidirectional waveform, it is touching the x-axis for every repeated intervals, whereas this particular output of a filter, you can see the output, it is increasing, decreasing, increasing, decreasing, but it is not touching the x-axis. And with the fine regulator, you can change this output to this fashion, and this output is known as the DC output. So exactly the purpose of a rectifier, when we talk technically, it changes an AC input to a DC output. But before giving a DC output, it has to go through this filtering process. So in our last class, we have seen a resistor, when it is a full wave, the output is obtained in this fashion, which is unidirectional. And these waveforms are generated with the help of a MATLAB model. We are going to discuss about that also. Then what you have seen, we have placed a capacitor parallel to a load, that is resistor, and we check the output, where you can see the unidirectional output is changed to output where you have the waveform in this fashion, and this is possible only because of the filter capacitor. So if at all you look into the model, we have the models of full wave rectifier like this. So I was talking about the first output in this fashion, where the output is obtained to be in this fashion for AC input. You can check the values. We have taken the AC input as peak value of 100, frequency is 50, and that is giving as input to the diode rectifier bridge, and the resistor value here, it is 25. So here it is 100 and resistance value is 25. So naturally, what will be the output? The output current, if at all you account it for, the output current would be 100 by 25, so it will be 4 amperes. So here we are not showing you the current output because we are interested in the filtering out the DC voltage, and that DC voltage here, it is taken in the shape of a unidirectional output. So you can see 100 volts input is changed to 100 volts output. What is the difference? Input, it is varying from 0 to positive 100, it is going to the negative 100, whereas the output of a rectifier, it is keep on uh, changing the values of low and high, but the value is maintained as 100 only, where you don't find the negative peaks. Okay, similarly beneath of this circuit you see a capacitor is there, and I have taken the value of capacitor to be 0.09, randomly I have chosen the value of capacitor, and when I'm checking the output, you can see here I got the output of 100, which is quite possible to maintain to a value of 100 without any interruption. Now what happens if I change the value of capacitor to some other value? For example, I'm changing the value of capacitor to 0.01, and let me see how the output would be. So once again I'll run over this interval. It is taken from 0 to 0.08. The stop time is kept at 0.08. Now you can see how the output it is. Whereas in the previous case, when we have made the value of capacitance to be 0.09, the waveform was almost, it was straight in nature, but when we change the value to 0.01, we can see the output. It is trying to maintain a DC value, but certain filtering is required. So for the filtering, what we have done, we kept the value as 0.09. If it only keep this value, let me check what happens. 0.099. So if that is done, we need to check how the output would be. Now you see it's almost constant DC in nature. So this is how the filtering capacitor show its impact over the rectifier output. Unlike capacitor, if at all we want to use inductor, we can use inductor, but remember we have to keep inductor in series with the load. So resistance is the load over here. So here in this circuit we can see a diode rectifier bridge is there, and an inductor is taken, and that inductor is kept in series with the resistor, and the output is measured across resistor and the source. So if at all that is done, what is the output would be? Now you can see here the value of input voltage is 100, right? So it is varying sinusoidally in nature, whereas the output of the filtered output of a rectifier, you can see it has started from 0, and the waveform magnitude it is reduced and it is maintained as high and low, and that is almost reaching to a constant value. What exactly we can see, the amplitude of the waveform it will be reduced and it will be maintained as a constant. So the waveform size it can be reduced to a normal or below normal size with the help of inductor filter. So for convenience, what I have done, I have taken exactly the output of the resistor, and that measurement I have kept to a mux, and where the output of rectifier when resistor load is kept, and the output of the rectifier when resistor is kept in series with the inductor, that we have clubbed with the help of a mux. Here this is called as a mux, where you can have a number of inputs and you can have one common output. So this has a mux, it is acting like a mux, and it is taking two inputs, and combined inputs I'm taking to a particular scope over here in order to understand what exactly happens to a output waveform when we are going to use inductor filter. Now you see here, you can understand here easily. Now this is the input of the voltage given as input to a rectifier, but the output of the rectifier you can see it is changed to 0. It has increased to a 50 above value. Then it is trying to maintain a low value with 50 and upper value approximately 70. So that change you can see here. And what we have done, we have taken the output of two circuits. Here the output of the actual rectifier and the rectifier with inductor, that is applied to a mux and it is measured over here. That variations you can observe with the help of this inductor filter. So likewise, we have to use capacitor filter or inductor filter based upon our requirements for the exactly the applications. So this fine tuning is done with inductor and capacitor filters. So this is the output of capacitor when we are placing parallel to a resistor. And in today's class, we have seen that inductor is kept in series with the load, and this is how the output waveforms which are obtained for a filters outputs of a rectifier. So that's all for today's class, where you have seen the filtering circuit. It is nothing but a inductor filter, and when it is used, the change of voltage is in this fashion. And if at all you have a fine tuning process, then you can change again to a DC value like this. So that's all for today's class. I hope you like this particular video. Please share among your friends, subscribe to this channel, and press the bell icon for the future notifications. Thank you.